my presentation will be on the energy transition in Colombia today. The issues that you wrote down are actually the issues that I'm working on in my dissertation project at Wuppertal Institute. So if it's okay with you, I will talk about the energy transition in Colombia today, if that's correct. What this presentation is based on is a research visit that I did to Colombia earlier last year, 2023, to Universidad de los Andes in Bogota, because in the framework of my dissertation project, titled something like you said, was part of the interest, how are energy transitions in global north connected to energy transitions in the global south? So I wanted to do an investigation on the ground. How is the energy transition going on in a country like Colombia? And I have worked on Colombia before, but I have not really known what the energy situation is. And I'm not sure whether you are, but I will present you some of my findings from back then, and will complement this with some of the more recent developments that we see in Colombia. So the presentation is mostly based on this working paper that I drafted from this research visit that you can access via the website of our institute. I'll have the links in the end, but complemented by other sources. So as said, what has an energy transition in the global north to do with global south energy transitions? And I would say a lot. My focus was here on comparing those two cases of Germany and Colombia. And we see that there are really long historical energy relations between those two countries. There is energy imports from Colombia to Germany. So this graph says is hard coal import or export countries to Germany. And you see Colombia down here. Colombia has always been an exporter also to Germany, not only, but also to Germany. Germany has imported coal from many other countries, but especially recently, after the Russian attack on Ukraine, we see that as a substitute to Russian exports to Germany, there was an increase, a substantial increase of Colombian coal. And not only this, in terms of fossil exports, there is also fossil exports from Colombia of oil, but also for the future, there are connections when we are going towards an energy transition, because global north countries, as you know, are very keen on importing in the future some kind of green energy sources like hydrogen or ammonia. And those should come also from global south countries. And Colombia is one of those potential exporters. So we'll have a look on whether that's a feasible option or not. Yeah, this is depicted in this graph. So I will present you lots and lots of graphs. You don't have to understand all the numbers. I'll just show you the gross picture of this. So these are major scenario studies for a German climate neutral transition. And what we see in the years 2045 or 2050, there will be substantial amounts of green hydrogen or ammonia that will be consumed in Germany. And the question is, where will it come from? And depending on the sources, you will see the red ones are domestically produced within Germany, and the green parts are what those models foresee should be imported to Germany. So it's really a big part. And this is where those energy transition connect. Okay, so I was told not to talk a lot about the general background of Colombia because I suppose most of you know, but just two things, because I will be doing some comparisons between Colombia and Germany. Colombia has about 50 million inhabitants, while Germany has around 80. The other thing, the total territory of Colombia is about 3 times Germany. So we see that in Colombia, we have large areas which are very scarcely populated, while Germany is in general very densely populated. And of course, the industry or industrialization situation in Germany is very different from Colombia's. This is why energy consumption also is a lot higher in Germany, and also greenhouse gas emissions. We'll have a look on this. I will not talk about all these kinds of different climate zones, productive zones, and what this means for an energy transition, and also not about land use change issues, which are important in Colombia, but I will focus here on the energy transition, so on greenhouse gas emissions from energy sources. And I will also not talk about the political situation, which is very complex in Colombia, as you will know, but this goes beyond what I can do here today. Okay, so the historical responsibilities for climate change are clear to every one of us, but just to recap, these are cumulative greenhouse gas emissions from world countries, and what we see that the bulk of emissions really stem from United States, Europe, and China, with Russia included here in European countries. And Colombia, you see somewhere down here, is really a very small emitter. So historical responsibility is definitely not so much with Colombia. But what we see when we compare it to Germany, we have 5.5 of total cumulated greenhouse gas emissions from Germany and only 0.2 from Colombia. But the picture is somehow changing. So in Germany, greenhouse gas emissions are declining. In Colombia, they are going up. So there is this breach is kind of narrowing down. And we'll see from this graph, we have fossil fuel emissions in Colombia, which are steadily going up. So this trend is going up and up. And the other part of the picture is a great part of the emissions in Colombia are not coming from fossil fuels, but rather from land use change. So this is very much about deforestation, about agricultural land uses, land use change, and so on. So also this issue, I will not talk about so much today, although it is very important in the Colombian context. I will just skip what Guterres said about all this. Just to say briefly that an energy transition for many global South countries is not only an issue of climate change or of mitigating greenhouse gas emissions, but it is very much connected to other issues. So it's connected to, as I said, deforestation, land use change issues, but it's also connected to energy security or energy dependency issues because some of those countries are fossil fuel exporters, others are importers, and changes to those structures are really essential also to any kind of energy dependencies. It's also an issue to international trade because many of those countries depend on export revenues from those fossil fuels. So when there should be a transition, then there is a question how to substitute those revenues or what to do with trade relation structures. And it's also a question of industrial competitiveness because quite some of global South countries do export other goods to global North countries like manufactured products or so on. And we have a continuing change in structures, in trade structures like the CBAM mechanism in the European Union, which is imposing carbon border tax adjustment mechanisms. So putting extra taxes to goods which come from countries which are not decarbonized. So in the future, any exports to the European Union will be more difficult if the own energy transition has not happened. And it's also a question of social and environmental issues when going forward with an energy transition, as we see in any countries where renewable energies are set up. So to skip the outline, let's jump in. As we saw from the first graph of total emissions in Colombia, this we can also see from a snapshot on only 1 year. So this is 2022. Emissions, how they're structured in Colombia. And what we see is really a bulk of emissions, about 60%, are not coming from energies, but from land use change, deforestation, and so on. And only about 30% of emissions are coming from direct energy combustion. Anyhow, I will not look at this green part, but I will focus on this energy part, because this is where really the technological questions come into place of how to organize an energy transition. This one is about other issues, about conflict, deforestation, how to halt that, and so on. And historically also, we have seen in the other graph that those emissions have been down to zero around the change of the millennium in Colombia, for example. So these can change relatively quickly, can change if they're addressed accordingly. While such an energy transition of this part really takes decades and decades because it involves changing all the infrastructures. Okay, no, I showed you already. No, I cannot ask you anymore. My question was, what are, in comparison to Colombian emissions, the German emissions? And you see, they're about a little more than double the Colombian emissions. And this, to me at least, was a real surprise, given the structures of the economies and also the population, which is quite a lot higher in Germany than in Colombia. And they are about double as high, but I would have expected the difference to be a lot bigger. The question is, or the reason for this is, of course, with this land use emissions, because if we look at only energy-related emissions, they are about 1.8 tons per capita in Colombia, while they're about 8.3 in Germany. And in Germany, this agricultural emissions and land use change emissions are only about 8% of total ones. So this is a big difference. And this is a kind of generalizable picture between many global north and south countries. Okay, so let's go into more depth into a sectoral analysis of what is the structure of energy consumptions and emissions in Colombia. The idea of doing this by sectors is looking at what could be done or what needs to be done to actually achieve an energy transition. This was kind of my research question here. And I find it more accessible if I go by sectors. Jump over this. So starting with transport. Transport is supplied by close to 100% fossil fuels in Colombia, which is the same as almost everywhere in the world. Half and half by gasoline and diesel. This is a typical transport situation in the city of Bogota. It's very similar in other cities. And the trends are going up. So total numbers of vehicles, be it trucks, motors, or cars, they're going up. And this is also a similar picture in everywhere in the world. So we see the same thing. This is historical numbers of vehicles going up. And this, of course, leads to increasing fossil fuel consumption and greenhouse gas emissions. And if you go to the numbers of the National Planning Unit for Mines and Energy, they also project a further increase of fuel consumption to until 2035. And even the highest one, about 80% of increase for jet fuels. So because there is no long distance transport infrastructure in Colombia, all long distance transport is done by plane. So this is the consequence of this. So this is when you look at what the National Planning Unit expects in terms of energy consumption. And I already put this graph here, it's a pity. Until last year, June, there was no strategy whatsoever of how to change this picture. So how to do any kind of energy transition for the transport sector. There was no plan, no real idea in Colombia. And only the current government came up with a first plan, a first idea of how this could be done. They published a strategy that's called a roadmap for just energy transition for Colombia, in Spanish, of course, but yeah. And this was the first time that there was a kind of strategy for all the sectors. And those are the scenarios that you will find in the strategy. I have the links down in the slides if you will receive them later on, if of interest. What we see there is a tendency. So this is depicting also this kind of picture, a tendency that's going up. That's energy consumption. This figure is energy consumption. And this is what so far always has been the kind of image. This is how things will go in the transport sector for Colombia. And for the first time in this roadmap, there was an idea of how a decline in energy consumption could take place. This is a scenario called just energy transition. And then they have a second scenario, which is one that would be compatible with the NDC, so with climate targets that Colombia has proposed to the United Nations, to the UNFCCC. Yes. So going to the residential sector, there it's different. In the residential sector, we have about a third of energy consumption, which comes from electricity. Another third that comes from, excuse the Spanish expressions in the report, it's all in English also. Another third is wood, firewood, and then another third is gas, natural gas and liquefied petroleum gas. And the uses those energy carriers are used for are electricity for lighting, refrigeration, cooking, hot water. Then we have the firewood, which is used especially in rural areas. It's also a similar case in many African countries. But there we have a breach between urban and rural areas. So in the urban areas, it's mostly gas, and in rural areas, rather firewood. And the question is how to decarbonize that. At least firewood is a kind of climate neutral source, and electricity in the Colombian case also relatively, but how to substitute those gas issues. And this has not been studied anyhow so far, but in this latest energy transition roadmap, there was some ideas. Yes. So this is the picture, what the roadmap says about the residential sector. And there it's interesting to compare what Colombia has promised to the UNFCCC for climate targets and what Colombia or the Colombian government perceives as to be just in terms of an energy transition. And the difference that we see here is that we have anyway a phase out of firewood for health reasons. That's always the argument here. We also see that natural gas should be phased out completely for reaching climate targets, but for what the government perceives as just, the natural gas is not phased out completely. And we see anyway a very large electrification of the residential sector. So bottom line, the government perceives for transition to be just, rather not reach the climate targets, but be just without reaching the climate targets. The industry sector consumes quite a large amount of carbon, of hard coal, and not carbon, but hard coal and natural gas. And interestingly, in Colombia, there is some 16% of bagasse, so that's rests of caña de azúcar. Ayúdame. Sugar cane, thank you. So bagasse from sugar cane, from this industry, and this is mostly consumed in the self-consumed in the sugar industry. Yeah, the question then is also how to substitute the coal and the natural gas. And there would be different options like using more bagasse, more electricity, so more electrification, or also biogas. So these would be options. And what the roadmap says about this is, in any case, the trend goes up. So energy consumption in the industry sector is anyway foreseen to go up for Colombia. But how should this be fueled? So all the trends say more natural gas, but in the transition scenarios, there is a phase out of gas, the gray one here. In what is considered the just energy transition scenario, there is no phase out of gas, but rather an increase of gas. They foresee substantial amounts of electrification, but in this climate target scenario, it's mostly electrification and no more fossil fuels. So similar to what we've seen in the other sectors. These are first ideas of how a transition could work. Then the electricity sector. This is also a very typical picture for many global south countries, where there have been installed a lot of hydroelectric power plants over the last, say, 50 years. The same is the case in Colombia. So 2/3 of electricity is produced from hydro energy and about 1/3 from thermal energy. This mostly from gas and from coal. And this obviously has to change also. I find it interesting to compare it to Germany, because Germany is in that case a lot back. We have only about half of the electricity produced from renewable energies and the other half from carbon and gas, carbon hard coal and gas. So this is a picture that's old from 2022. There was still nuclear in there. Nuclear is closed down by now and substituted mostly by renewables. Yeah, this is my Spanish. Eólica is wind energy. So the problem which many global south countries face is that electricity consumption is going up. And this means that at any place, every year, new capacities needs to be added. And for those of you who know the Colombian case, back in 2021-22, there was a big problem with a new hydroelectric plant called Hidroituango. That's a huge, I think, 2 or 3 gigawatt hydroelectric power plant that almost broke down because of too heavy flooding of the dams. But anyway, the government needed to get this plant to the grid. And the reason is that electricity consumption was going up and actual current capacities were not really sufficient to meet the future demand. So this was the reason why the government was really pushing for going forward with Hidroituango, and by now it is running. And additional capacities are added. So this is what's happening in so many of global south countries. Additional capacities need to get into the market, and fast. The question is now, in a situation for an energy transition, which capacities are getting into the market? And there we see that actually renewable energies are already relatively competitive with thermal energies. So gas or carbon plants are not so much built anymore, just because it's very uncertain how gas prices will evolve in the future. And in return, solar or wind energy are relatively competitive. So without going into the details, what we see that, excuse me, from this graph, that the big capacities that have been added, this graph is from last year, the big capacities that have been added were really, in this case, solar energy, and in the pipeline, there's a lot of wind energy also for Colombia. And this is also to be seen in the scenarios for the future. So there will be a maintenance of the production from hydro energy, but all the new capacities that are being added is the purple ones are wind energy and the yellow ones are solar energy. So there's very little thermal energy to be expected in addition. So going to fossil energies in Colombia, what's the situation here? The first one is hard coal. It's highly interesting if this is petajoule. Excuse me, I didn't put the units here. This is petajoule. The extraction in Colombia that we have of hard coal, that amounts about to 55 million tons of hard coal in Colombia. And you see that almost all of this, or basically all of this, is exported. We have a very minor consumption in the country. This is final coal consumption within Colombia that goes to industry, and a very small share that goes to thermal power plants. And virtually all of the mined coal in Colombia is being exported. For natural gas, the situation is somewhat different. We have this amount of 674,000 petajoule being exploited of natural gas, and about half of this consumed internally. But what about the other half? We have some small share that's burnt in central power plants, but the rest, the big share is this one. It's about a third of overall gas exploitation in Colombia is being used for injection into oil wells to explore more oil, to raise the pressure to oil sources. So it's actually this exploitation is not being used for gas, but only for additional oil exploitation. And crude oil is being also extracted in substantial amounts in Colombia. Also, about half of this goes to national refineries for then fueling the transport sector. And the other half of this exploited oil is being exported. I'm running out of time terribly, but just to quickly have a look on exports and imports. as I said before, this is also a question of international trade. Of all exports, of all Colombian exports, it's about 55% of export revenues come from hard coal and from oil. So it's a substantial amount, and Colombia really depends on those exports. And this becomes obvious when we also put into balance the imports, because there is a substantial deficit in the trade balance, as you see. So Colombia cannot easily miss out on those exports just in terms of the trade deficit. That makes a phase down of those exploitations of fossil fuels really hard, or puts an additional hardship. And this becomes additionally problematic because those reserves that Colombia has, well, for hard coal, they are indefinite almost in Colombia, but for crude oil, they are really limited, and it's very, very similar for gas. So gas and oil resources in Colombia are very limited, and there are expectations that by already 2026 or 27, Colombia could become a net importer. And if we look at graphs like this, even by 2030, 40, those reserves, that's gas reserves, could be entirely diminished, so that there will be no national exploitation, basically. So this puts additional pressure to Colombia because they need to substitute domestic supply and also the exports. Okay, so I'll just rush. I will skip this. Where could then renewable energy sources come from in a country like Colombia? And this is now a map of wind energy potentials in Colombia. What we see is that the major wind energy potential is in the north, on the shore side, and especially in what is called the Guajira Peninsula, and the offshore regions around the Guajira and all the Caribbean coast, the northern Caribbean coast. So this is where conditions for wind energy are really among the best worldwide, and has rushed a kind of gold rush towards wind energy projects in Colombia. So there are already billions of dollars dedicated to these kind of projects. But there are problems because precisely this is one of the poorest regions of the countries that has been not very much attended by the government in the recent decades. It's additionally an area where indigenous people from Wayuu ethnicities live in, and also these areas are biologically very sensitive areas for putting offshore wind energy projects there. So this is where currently there is a lot of fight in terms of human rights and ecological problems. The second point is, of course, solar energy. Let me just say, there are a few other wind energy potentials along the mountain ranges here. And there is so far in Colombia not really much discussion about putting wind energy somewhere else than only in the north. So this would be, for me, something interestingly to be explored, what is happening about those regions. But I have not seen anything about this. For solar energy, the potentials are a lot more widespread across the country, and this is where actually quite some activity is happening already today. I know you're looking to the clock. So maybe I'll skip that one and look only at the total figures. What I've done in my research in Colombia was trying to look at, don't look at the figures, I'll explain you. Try to look at how could we substitute those fossil energy consumptions with renewable energies? And this was the kind of calculation task that I tried to do. We have these fossil fuel consumptions today, or foreseen until 2036. What if we substituted those fossil consumptions by electricity? So these would be then electricity amounts that would be needed. And I calculated what roughly would need to be the additional renewable capacity to fuel those additional renewable electricities. And what I came up with, just to roughly summarize, some additional needs of 110 between 88 gigawatts of renewable energy to be installed in Colombia to really fuel such a sustainable energy transition. And when I did those calculations, there was no study out there, but now we see from the roadmap what they came up, and actually they came up with very similar figures. Okay, that one is here. This is what the roadmap says. They are very much in the same range. So apparently I did my calculations relatively okay. But what I found for a total renewable energy potentials, the sources that I could find are 138 gigawatts. So if this is true, then this would also already go towards the limits of what the potentials are in terms of renewable energy in Colombia. But again, I don't really believe those figures. I think there is some more studies needed, because for Germany, we have some 450 to 600 gigawatt of renewable potentials in a territory that's only a third of Colombia. And that's not really, that doesn't fit. So there needs to be more studies on this. Okay, so this is what the capacities, the roadmap comes up. And just one thing, because this is important, what they say for those just energy transition or climate target scenarios is a substantial increase in the renewable capacities. So this is what we've seen in the previous figure. But the difference they see again between the just energy transition and climate targets is here there is no phase out or no total phase out of gas. And another difference is that in the climate target scenario, there is a higher capacity expansion, but these higher capacities are all needed for the national energy transition. While in the just energy transition scenario, there is fewer capacity expansion and additional exports of green hydrogen to global north countries. And in return to that, no full decarbonization of the local economy. So this is what I think is the interesting question. This is again the hydrogen issue. I'll just skip that and go to the end. What we see is basically this kind of trade-off. Either we do a full decarbonization of a global South country economy in coherence with climate targets, or we do what their government says is just energy transition, and we take into account all these trade problem issues, and we don't do a full decarbonization of the local economy, but instead we do some additional green hydrogen exports to global north, and have the export revenues from there. So this is the difference I see from those different strategies, and I'm happy to discuss with you how you see this and what would actually be a just energy transition. Because from my perspective, I would rather say we should look for a full decarbonization of global South economies, of their own economies first, and if then there is additional potential for exports, fine. But first, it needs to be secured that also those economies can really decarbonize and not be trapped in these kind of trade balance deficit problems. So there needs to be another solution for the trade balance deficits. Thank you.